Welcome back to Neurolize. I'm Zerya, and today I will be presenting the subject of numerous movies and TV shows for decades, mind control. So my question is mind control possible, or is it only a thing that can be found in science fiction novels? Well, if you're interested, keep listening and find out. Before diving into the possibility of mind control, how about we take a look at the history behind it first? Forget about all the books, comics, movies, and TV shows ever made about mind control. Mind control was a thing in the 20th century. Numerous studies and interviews have shown that, under the cover of the MK Ultra program, the CIA funded covert mind control experiments on unsuspecting Canadians during the Cold War. This is just an example, but it was later found that there have been several more incidents where people claim to be in mind control experiments conducted by the CIA during the Cold War. But it's not just the CIA. Reports also show that during the Cold War, the Soviet Union spent money on mind control weapons as part of its weaponry race with the United States. It is estimated that they spent around $1 billion on mind control experiments. The findings indicate that in an attempt to manipulate other objects, the Soviets created a machine known as Certain that could generate and store the high-frequency electromagnetic radiation released by the human brain. Okay, so enough with the failed attempts throughout history. Let's see what today's world is doing about mind control. There is this new method called optogenetics. Optogenetics offers a method for selectively activating a collection of related neurons that all express the same gene. This is advantageous since it allows us to look at a limited number of neurons while still gathering sufficient data to help us understand how the brain can operate. But how does optogenetics work? Let's find out in more detail. Since neurons do not typically respond to light, they must be modified to do so. This modification should only be made to a particular portion of cells that share similar genes, allowing us to determine the precise function of these cells. Most of the time, a virus is infected into an animal brain or a cell culture to do this. The cells this virus infects develop an ion channel called channel rhodopsin, which is almost equivalent to the light-sensitive proteins located in your eye. When a specific wavelength of light appears, this channel integrates into the cell membrane and opens, allowing positively charged ions to enter the cell and forcing the neurons to fire an action potential. An electrical signal is known as an action potential. The channel rhodopsin will only be found in the membranes of those cells because the modified virus also carries other proteins that make it unique to a specific type of neuron. Because neurons fire in millisecond blasts, light is a highly effective trigger. Drug activation of specific cells can be accomplished using similar approaches, but only light can be turned on and off quickly enough to properly control the neurons. We now know how to carefully and successfully regulate a tiny group of neurons. But what does this mean? Numerous studies from hundreds of labs have looked at the operation of various small groups of cells in the brain since the invention of this technology in 2005. Decision-making, memory, learning processes, which were previously believed to be the sole purview of psychology, now have a much more solid neurobiological foundation. And we also know a great deal more about the circuits involved in fundamental processes like sensing and movement. For instance, by introducing only brief bursts of light, it is possible to simulate in an animal that has never seen this object before the feeling that something new has been learned or seen. When presented with a new item, they act as if they have already seen it despite not having it. Optogenetics has been used to examine a variety of neurons participating in illnesses like Parkinson's and Alzheimer's disease, schizophrenia, depression, and addiction, which is assisting us in our search for successful treatments for these circumstances. This technique has effects on human health and disease. Despite the fact that there is still a great deal of research to be done before we can say with certainty that we fully comprehend the human brain, this technology is constantly developing and has a lot of potential. So even though it may seem like a dream or even a nightmare, perhaps mind control will become a common occurrence in the future. And even though there is a broad controversy over the ethical perspective of mind control, I honestly believe that research regarding it must continue. We still have a lot to learn from our brains, and the research must go on no matter the circumstances.